Bismillahirrahmanirrahim. Starting with the name of Almighty Allah, the most beneficent, most merciful. So today the dilemma of the talk is resonance. I did talk to you what a resonance is. That is to and fro motion from the central point. This was the literary meaning. Now we are going to apply it as the resonance method. How could you be able to find out by various method, means, options to opt it and know there is resonance, and those are the structure which has got alternate single double bond in them. They possess the resonance, and in that respect I am going to deal with now the structure of carbonate oil. And now here is that one. This is the carbonate oil. Consider now the carbonate oil, CO3 -2. According to the Lewis theory, it may be represented by the following structure. Now you can understand C double bond O, oxygen with a negative charge. Again there is oxygen with negative charge. Now we have to prove this bond length, this bond length and this bond length is exactly equal. But sometimes you thought these are two equal and this is not. But it is. That is to be proved, and due to this double bond there is resonance, and that resonance let it to be having three equally distant things. This we have to prove now in that respect. However, there is a physical evidence that all carbon oxygen bond, this and this bonds have the same length in the carbonate oil. This is the carbonate oil, and this bond length, this bond length and this bond length is all alike. But sometimes you can think this should not be equal to this, but it is. That we have to prove, and proving authority in that respect is this double bond. That double bond, single bond, single bond, double bond, double bond, single bond. This is the conjugated system, and this conjugated system would be able to prove that this bond length, this bond length, this bond length are equidistant. Could you be able to understand here? If you cannot, please do talk to me, and I would be able to let you to answer it. Now you can talk to me to whatsoever media. According to resonance method, the equivalence of the three carbon oxygen bond length is accounted for by writing a set of three structure for carbonate oil. Now this is the carbonate oil. Now what happens in this case? You can see these pi electron will move here, and this will require a negative charge, and there will be double bond here, no negative charge. Those negative electron are here. But then there's another oxygen which has got a negative charge upon it, and the third way of presentation is this pi bond will move here, and this will require a negative charge, this will require a negative charge. That won't have the negative charge. Those electrons are here. Now this is the physical presence. Now how you could prove all these three bonds are equidistant? Credit goes to this double bond, which is responsible to let us to say and let us prove it that all these three are equidistant. Now we are going to share with this. In this respect, what we have to consider, in any one of these structures, the negatively charged oxygen atom are different from doubly bonded oxygen. Now here is that one. In any one of these structures, 1, 2, 3 structures, in any one of these structures, the negatively charged oxygen atom, this is negatively charged oxygen atom, again negatively charged oxygen atom, are different from the doubly bonded oxygen atom. Now you can see this don't have got any negative charge upon it. That is why it is different from these two, which has got clearly negative charge upon it. that the negative charges are localized on only two oxygens. Here you can see this is one oxygen, another oxygen, and negative charge is localized here, and there is no negative charge upon it. Again, you can see this is negative charge, here is negative charge, there is no negative charge. Now here you can see again, this is got a negative charge, this is got a negative charge, but there is no negative charge here. Now you can understand this thing. Doubly bonded atom oxygen is quite different from rest of the molecule, while the pi bond is restricted between the third oxygen and carbon. Now you can see this is one carbon, second, this is the third one, and this pi bond is this pi bond. If you write down like this, so you can see these are the electrons. These are the electrons which reside here. While the pi bond is restricted between the third oxygen and carbon, the resonance picture, however, shows that the electrons comprising the pi bond and the two negatively charges are delocalized over the entire molecule. Now you can understand. Now, this is pi bond, and this pi bond again has got a negative charge. This is negative charge, this is negative charge. Now what does that mean? While the pi bond is restricted between the third oxygen and carbon, this is, these pi electrons are here, and the resonance picture, however, shows that the electrons comprising the pi bond and the two negative charges are delocalized over the entire molecule. Now you can understand. In this way, electrons, and these are the electrons, these are the electrons. Now these electrons delocalized over entire molecule like this, like this. Wheresoever you could see the distance would be equal. So this is the way which can let you to know that this pi electron also has been delocalized upon over here. If they weren't having the double bond, situation would not be like this. We carry goes to this double bond, which is responsible to have three carbon oxygen lengths equal. If you could be able to understand this, please let me know, and if you cannot understand, don't hesitate to ask me about it. This is a crucial point you have to learn. If you could be able to understand this resonance theory till death, you will be able to understand the structure of every compound, every coming drug, every carbon, hydrogen, oxygen containing entity. Otherwise you will be keep on lacking, and you cannot produce yourself as a professionally competent and legally qualified. Do listen to me, my son and daughters. This is very important point which should be very clear to you. Once when you will be able to understand the structure of the compound, then you can understand what it will do in the body and how it will enter, and it will metabolize and will excrete and will produce the desired effect which is required, and then how it will produce the toxicity inside. That is the point. If you can understand, please do talk to me. Anywhere, any moment, any time, except my sleeping time, which is 11 p.m. to 4:30 a.m. early in the morning. So now, again, I would like to make it clear to you, that is, while the pi bond, this is the pi bond, is restricted between carbon, oxygen, and the negatively charges are delocalized. This is negative charge, this is negative charge, and the pi bond also contains electron in it. So these electrons are revolving like this, like this. It is a sort of radius which has been formed, and the radius has got R equal from anywhere. If this is the center point, equal, like that. So these electron, this is electron, this is electron, they are like this, moving in this way and taking these electrons with itself. Or another way around, you can say like this. So this thing goes on, and let it to be carbon-oxygen bond equal, carbon-oxygen bond equal, carbon-oxygen bond, equidistance in any case. Please, if you can't understand this thing, this is the crucial point to be understood at this moment. That's why I have taken this theory with me, because it's very difficult task to let it to be explained in theory. And if you could be able to understand, you can understand everything. Shows that the electron comprises pi bond to negative charge are delocalized over the entire molecule, and that in the actual carbonate ion all three oxygen atoms are equivalent and therefore equidistant from the carbon atom. That is the point. However, there is physical evidence that all carbon-oxygen atoms have the same length in the carbonate ion. According to the resonance method, the equivalence of the three carbon-oxygen bond length is accounted for by writing a set of three structures for carbonate ion. These are the canonical structure. I did mention to you, double-headed arrow shows the canonical structure. Canonical structures. Now, they are canonical structure of each other. That means if you hybridize it, so what will happen? What will be the picture? If the third picture would be like this. Now, these are visualized, which you can think. And where is the actual structure? Could you understand? Can you answer it? And if I could say, this will be in your imagination. The techniques of writing the resonance contributing structure may be illustrated by a few examples for conjugated system of the time. A double bond B single bond X. There is these two electrons are residing over here, where the two dots represent an unshared electron pair on the atom X. The following steps are involved. Now you can see these are the pi electrons. These electrons can move here and this can go here. This can take a positive charge and this will require a negative charge. That can be represented as follows. Now, write down a single conventional structure showing also the unshared electron pair. Now you can see these are unshared electron pair. Number two, move the unshared electron pair on X towards the double bond to make new bond between X and B as shown by the direction of the arrow. Now these are the electrons, move here. Now you can see these electrons will move here and then these electrons will move here, pi bond. Number three, move the bonding pi electron pair between B and A towards A. These are those move in this way. And fourth is write a unit positive charge on X. As X has donated the electron, it is deficient of electron, therefore it will attain a positive charge, and A has taken the pi electron from here, it will definitely attain a negative charge upon it. Net negative charge on the atom A. Now you can see this is that one. It can be written in this way. Now the two contributing structure that will result from the above representation are as follows. Now you can see these are the two ways which you can write down. Now these pi electron move here, these pi electron move here with the canonical form which is there in double-headed arrow. This will attain a negative charge and this will attain a positive charge. Now due to this pi double bond, you can write down this thing in this way also. The carrier goes to this pi bond. This is due to the resonance which is there in. The resonance picture of the vinyl chloride A and acetamide B, which are as follows. Looking at this is the A double bond B single bond X time as derived by the above technique. If this is A, this is double bond, this is B, and this is X. Now these will move here, and this will move here, and so now you can see this will attain a negative charge and this will attain a positive charge. Similarly, the acetamide, in this you can see CH3, C double bond O. Now this is A double bond B single bond X. Now this will move here and this will go here, and this will attain a negative charge and this will attain a positive charge. Now you can understand how does these technique let you to know how to understand the structure of a compound. So if you could be able to understand the resonance theory, you will clearly be able to understand the pictorial presentation, actual presentation of the molecule, and you can react one molecule with another so that you could be able to get exact product which previously was not known by the scientists, while the resonance theory was not there. And previously this was the only molecular orbital theory that has been prevailed. But the most important theory in this respect is the resonance theory, because 70% of the molecule which are being made in the medicinal chemistry, in the pharmacy, heterocyclic compound, and those heterocyclic compound has got the structure like that. That's why for the pharmacist to understand resonance theory is very, 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 very important. We are currently dealing with the techniques of resonance, and in that respect I already did discuss the technique number 1. Now another technique that is called as technique number 2 for compounds for which one conventional structure is of the type A double bond B single bond X double bond Y. How that can be presented? Other structures are drawn by moving electron in the direction of arrows. Now you can see these pi electron move here, these pi electron can jump in this way, and another way is these pi electron can move in this way and another pi electron could move in this way. So these are the two ways. In the first case, unit positive charge on Y. Now you can see pi electron from Y moves towards X. Now then from B, pi electron moves towards A. Now in here, A is acquiring electrons. Definitely the A will attain a negative charge, whereas from Y electrons are moving and dragged on. Therefore Y will definitely be attaining a positive charge. Now in the first case, a unit positive charge on A and a unit negative charge, or unit positive charge on Y and a unit negative charge on A is written. And in the second case, as it is, from A pi electrons are moving towards this, and then from X pi electrons are moving towards Y. Now you can see Y is attaining negative charge and A will definitely be attaining positive charge. Now the three structures of the above molecule therefore will be, this is the actual structure, conventional structure type 2, and again this is the one where A acquires a negative charge and Y acquires a positive while electrons are moving in this way. Now another is, while the electrons are moving from this to this, A will attain a positive charge and Y will attain a negative charge. Now the typical example of in this case is as follows. Conventional type number 2 typical example is 1,3-butadiene. This is a compound of the above type and its resonance description is as follows. Now CH2 double bond CH single bond CH double bond CH2, A double bond B single bond X double bond Y is therein. So similarly, if the electron will move from here to here, this part will attain a negative charge and this will attain a positive charge. Similarly, vice versa is also true. So this was the pretty good example of second type of conventional compound. Now third type of conventional compounds are for compounds which might have a conventional structure formula of the type A double bond B single bond X with a positive charge. Previously there was a negative charge. Now in the third conventional technique, there is positive charge. Other contributing structures are written by moving the pi electrons between A and B towards positively charged atom X to make a new bond between B and X. Atom A then gets a unit positive charge. Now you can see these pi electrons are moving toward this side. Now this is herein, and electrons have been dragged down from A, therefore A will attain a positive charge, whereas X won't attain a positive charge because already deficient electron was therein, and those electron has been incorporated into it, therefore no charge will be upon it. So its pretty good example is allylic cation is typical of this category and is considered to be a resonance hybrid of the following two structures. Now A double bond B single bond X with positive charge. Now electron will move here and the electron will jump up here, and the deficient electron will be fulfilled. There will be no positive charge, and contrary to it, positive charge will be attained by this part of the molecule. So there are basically three techniques which could be presenting the entire chemistry: technique 1, technique 2 and technique 3. If you could be able to understand it, कवर दिया कंधा तक तुसी बड़े प्यारे फार्मासिस्ट बन के रहोगे और कोई दुनिया की ताकत ਤੁਹਾਨੂੰ हिला नहीं सकेगी. Thank you very much. Listen to it, and if you could not understand anything, you can talk to me anywhere, any moment, any time, except I talk to you while my sleeping time, and that is from 11 p.m. to 4:30 p.m. early in the morning. Thank you very much, my son and daughters. My mobile number is 0300416375. Whenever you like, you can call me and I will be there to explain it to you. Thank you very much. Allah Hafiz. Fi Amanullah.